Hello friends. In my previous video you must have learned what is electrostatic potential, right? So now you have everything that you need to understand what is electrostatic potential energy by understanding what is electrostatic potential. Now what did you learn regarding electrostatic potential? What is electrostatic potential? Let me just brief out just to make sure you remember everything. Okay, so let there be a charge plus q over here. Okay, and you are trying to bring a unit positive charge which is like plus q naught from infinity to this point, right? Now since this is there, you'll have electrostatic field over here. So what is electrostatic potential? V is equal to the work done by external force or work done by you in bringing q naught from infinity to this point, right? So this is V, that is electrostatic potential, correct? Now what is the work done by you? Reframing this same thing, you can write it as q naught into V. So this is the work done by the external force or work done by you in bringing q naught from infinity to this point A, correct? Now instead of bringing a unit positive charge, in case you bring a charge which is just q, okay, this is where you have the concept of electrostatic potential energy. So let me write the heading now, electrostatic potential energy. Okay, now what is that? The work that you do. Now before you had q naught, I'm sorry, I repeat, the work that you do in bringing q naught is q naught into V, where V is the potential due to plus q at a point A. I repeat, V is the potential due to plus q at a point A, right? And that was q naught before. Now I'm changing the whole scenario. What I'm doing is I'm keeping this plus q as it is. I'm changing this q naught to q. It is no more a unit charge. Then what will be the work done? The work done will be q naught. I should remove and replace it with just q. So this is the work done by external force or work done by you to bring q from infinity to this point, correct? Now where has this work gone? This work done is stored as potential energy of q. Okay, so you can write it as u is equal to q into V, where V is the potential energy, where V is the potential energy of q in the presence of electric field. What is the electric field due to? Electric field is due to this charge over here. I hope you understood. Okay, so this is the potential energy. So potential energy of a charge in the presence of electric field U is given by Q into V, where V is the potential due to that charge at that point. Okay, now what is the SI unit of that? SI unit of U is, since it is energy, you can easily say that the SI unit is joule, and U is a scalar. U is a scalar. Potential energy is a scalar. Now what is change in potential energy? Delta U, how do you write that? You can write that as instead of bringing this plus q charge from infinity to this point, suppose you have a plus q charge over here which is this, and due to this there is electric field, and you are bringing another charge from some other point. I'm sorry, I'll make some space over here. Okay, now you have a plus q charge here, you are bringing another charge q, not from infinity this time, but from a place here to here. Okay, so let me call this point as A, call this point as B. So I'm bringing Q charge from A to B. Alright, so then what will be delta U? Delta U will be the work done by you in bringing a charge from A to B, that is written as WAB, which is equal to UB minus UA. In other words, you do some work in bringing Q from infinity to A, and then from A to B you do it. Okay, so the difference between the work done by you in bringing it from here to here is nothing but the difference in the potential energy of that, which is given as UB minus UA. Okay, so this is about the potential energy of a charge in the presence of electric field. So the definition of potential energy is potential energy of a charge Q at a point in the presence of electric field is defined as the work done by external force in bringing the charge Q from infinity to that point. And the change in potential energy delta U of a charge Q is defined to be equal to the work done by the force in carrying the charge Q from one point to the other. Okay, I hope you understood. We'll do the same derivation using calculus in my future videos. Okay, thank you. Please do comment if you have any doubts. Thank you.